Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Peter Leyland of National Surveying Cadastre. Peter is a longtime FME user whose work with FME started in 1997. His particular area of expertise is in mapping files and TCL.
What I'm going to talk about today is also useful in relation to workbenches, and some of the stuff Dimitri talked about before is also ideas I'm using, I'm working with. So, but what I'm interested in presenting in this discussion is when we move from a simple desktop application where a user is translating data, and we move it into a mapping or into a FME server, batch jobbing, and so on, where we might run hundreds of jobs per day, and so we need some extra functionality, and that's what I think is why I call it applications. So we need to add an extra layer of functionality around the actual data translation, and it's some of the ideas I'm working with in this respect I'm going to talk about. And just a note, last time I lost my voice, so I couldn't give my presentation. But so yeah. So I work at the National Survey in Denmark. We are a government organization producing cadastral topographical data and nautical charts, also implementing the Danish Inspire legislation. So I'm involved in all kinds of that. And my job is basically to be able to distribute bulk data sets to our end users. So I have to set up different kind of services using FME server, FME batch jobs, etc., web interfaces, and so on. So that's the environment I'm working in. So you could say my challenging is to develop solutions that are flexible, easy to maintain, robust and able to handle errors. There's a lot of errors in data. We can't avoid that. So we have to somehow implement things in our mapping files or in our projects that will handle errors and notify the administrators or developers that something has gone wrong. My focus will be on the ideas I'm working with, not so much the actual implementation. There will be a few examples, and but if we see on a typical project I'm working on, we will have some input data and some output data, and there will be some kind of FME in there. There's also the FME end and begin TCL. When I say TCL, that's why I'm in love with TCL. Somebody accused me of being obsessed with TCL in their Google group once. But I love it. But you could use Python as well. It's integrated the same way. So I say TCL, but you could use Python. So that would be a typical desktop solution. You have translate something, and but what I'm also working with is when we have 100 jobs going a day, we can't use the log file, so we would have a log database. So every job is logging into a database, an Oracle database. So, and to get reports out of that, we can use FME to actually read it out and put it into some HTML files, and we can publish them on our server. So the people having contact with the customers will be able to see that the things is up and running, so they don't have to bother me to ask about that. So Dimitri talked about, those of you who attended his last session, he talked about having a master and a slave mapping file, a mapping file driving another. And Jeff Connon is, I think, giving a presentation about this as well. So it's a very powerful way to actually have a master mapping file driving the second mapping file. It can read some input parameters from the job database, and it would log into the database. The actual mapping file is also, it will read a job ID, so we know we can connect the different logs together, so we know what kind. And all this is starting using bat file or URL or command lines, whatever you like, to how to start it. UltraEdit is my favorite tool for working with FME. I call it just for fun up there. I designed this way of working, this design way 5, 6, 7 years ago, I think, and published it on the FMEL at that time. And I just did it for fun, so I just call it just for fun. So if you go there, you can find a mail with that title. But I think it has improved to be a very powerful way of working with FME. And I mean, I can see it's popping up now, and you can even do it in Workbench with what's it called, workspace submitter transformer. So in the topics I'll talk about a bit about is design and error handling in the main mapping file. I'll talk about this master-slave design I'm using. A bit about post-processing and pre-processing using FME and TCL logging, of course, and the job database. Ideas I'm working with there right now. Just small. I use mapping files. I'm brought up with them for many years now, so I can't get used to the. It has some advantages, I think, but Harbinder last time asked me, when will you start working with the Workbench? And I think I said never. Dale has seen me do it once. But basically, I mean, we have different levels of control over FME. We can, I mean, if we have the FME GUI, we can just pop up, say, translate this to this, and FME will do the job. The same with Gentrans and so we have the Workbench. We can do a lot with that. We might be able to do a little more with the mapping files than we can with the actual Workbench, and of course TCL, Python. So it's a trade-off between control and ease to work with. So I used to ask this question. So can we see some hands, please? Anybody using mapping files? Peter is, and Ulf is, Dale is.
Once in a while.
Once in a while. There used to be some more, so maybe you were doing it as well. Okay, so not many, but there's advantages doing that way as well. So yeah, we can do looping here, and so there's a very powerful way of working with this master-slave. We'll talk a little more. Right now, I'm working on a project where we will deliver hundreds of data sets to municipalities and so on. So what I'm working with now is actually to creating a database that combine the job database with jobs to do, when to do them, with our log databases to see when did it last run, with the input database to see has there been changes in there, so we can get changes for the customer. If there's changes, they need to get a new data set, and our customer relation management system, so we know which customer is going to have what data set in what format, projection, and what's the notification emails. So to combine all this and to actually move all the logic about when and how to run the databases, or when and how to run the different jobs into the database, and then just let the database do the job. There will be a number of views, and FME will just read these views and translate them into command lines and run the. So this would read it. All attributes would go into a macro, and then it would just run the master or the slave engine doing the actual work. It's a very flexible design. We can do a lot of things. This is a project that I asked Ulf and Peter to do for us, and where we use Gentrans, and the slave is just reading out. So we actually have 3 FME engines running in a row. The one deciding what to do, the next is describing the job for the last FME, using it in Gentrans mode. And So, and we can log it all. And so the advantage of this master-slave is we can use the FME toolbox to control. So we can stay within one environment. We don't need to go out and use a lot of VB scripts or C# or whatever to control FME. We can stay within one environment. We get an extra level of error handling, so we can check that the slave job is actually executed, even though there is means within FME and TCL. Sometimes it don't grab all errors, so we can have an extra level of error handling. We can split complex jobs into more simple jobs. That was in a way what Dimitri was talking about. But you can also say we have some part of the job that is depending on other, and so we can add looping and so on. Looping is very good if we have a web-based interface where the users can have maybe a more simple interface, because we can do a pre-processing of their request. And the database-driven batch jobs, we use Oracle, because we use that for our data. So, but you can use any kind of database. That's the power of FME. It doesn't care whatever you're using. You can CSVs, Excel, so on. So just a way to do how to do it in TCL. I will not go so much in it. We can. But if you're using the FME server control X file to execute that, we can actually access the FME server that way, rather than using just FME exe. We have the workspace runner, we also have the job submitter factory Dimitri was talking about. And we can run it synchronously. We can run it, let the masters wait for the slave to finish, or we can tell, especially with the server, that do it in whenever you like, when there's time. So it gives a lot of, makes it easy to administrate a lot of jobs and the servers and so on. So dynamic mapping files is talk a little bit about the design. There's a lot of interesting things going on in Workspace now also. But basically a dynamic mapping file is a mapping file that changes as a result of the input parameters. It gives a lot of flexibility to, and it makes what I think is it's generic and reusable code. You can you can it take a little longer to design, but you can then I mean, you have a more simple actually result in the end. And it has a better performance. I've done some small performance tests with some of the examples that have been published on FMEpedia. And I think with a mapping file, you can do it 2 to 3 times as fast as you can do it with a Workbench file, because there's a lot of overhead going on. Basically, the Workbench is generating a mapping file that is executed. So, but there's a lot of overhead in the... So in key elements is normalizing the data into an output neutral format. A great advantage of this is that we have a standardization for it. And we use schema mapping using external metadata tables, which is a lesson I think Dale will tell everybody that they should use. So and basically there will be a lot of files on the computer, and it will be assembled. So there's a number of readers, and based on the input macros, it would take the correct reader and collect the necessary transformers into the whatever output format we are interested in. And what's interesting is, of course, we have a lot of metadata tables, so keep all kind of hard coding out of the actual mapping file, but use dynamic schema mapping and so on. So. And this is an example just of a little snapshot from a mapping file I use. So you can see it's a lot of includes, a lot of TCL scripts and macros and so on. And they should know that up here, I do all the sourcing and then I just call it. That's a new feature. It used to be that one of these includes would start up its own TSL interpolator, making it very slow, especially in Workbench where there's a lot of these behind it. So now we can just include all the code in top and then call the functions whenever we like them within the workspace. So I call it thin pipelining. Dale and Don used to travel around with a thick pipeline and a thin pipeline. So, but this is again the schema mapping idea. You should try and let the pipeline do the logic, and then the actual rules or the actual mapping from one feature type to another should be in external databases using schema mapper or at relate or relate factory or whatever. But try and it also means that users can actually update the metadata tables without knowing anything of what's going on within FME. So we can actually, as a developer, move away from that. So. Error handling. There are no error-free data sets and there are no error-free scripts. So we have to develop some kind of mechanism and take care of that while we are working. A few months back, there was a discussion on the Google group about somebody running a 4 or 5 hour translation, and then there was a missing attribute in a computation that made the whole break down. So there should be some kind of mechanism within the workspace, within the mapping file, taking care of that. And if there's an error, we should have mechanism allowing us to report that error to the developer. Or so if a mapping file breaks or a script breaks down on a server, I mean, you should send a mail to the administrator that something bad has happened. Also, if it finds bad data, it should log them and put them into FFS files, is what I use, but there you have all the attributes, and I can go in and look and say, okay, there's some data I have to report to the production department they have to look at. So we basically have different error types. We have parsing errors, which when it's reading the mapping file or the workspace, it fails because the syntax is wrong. You probably don't have that in Workbench, but then there's logical errors where you get a wrong result, but it's because you did something wrong. So that's very hard to actually find. But what we sometimes experience is that we have environment errors, what we call them. It's that we lose the connection to the database, or a drive is missing, or the temp drive run for full, or something like that. And then there's the data error, and we can discriminate between geometry and attributes. Other people have already been talking about today about how to handle errors in data and validating it. So just a small example here where we do an offset using the offset function, but within a TCL script, and we use an attribute to do that, and we just test the attribute before it, and if it's not a number, we add 0.0, so we give it a default value. A different example is that we have a test factory and do an at relate, where we go to a database to fetch some data. If it's some kind can't join that, we add an attribute saying that it is, well, we add an attribute if it's okay, and then we'll just pass on. If it's not having that attribute, I add some error coding and give it the feature type KMS arrow, and it would, in the end of the mapping file, go into a FFS file, and this way I can go and look at the problematic data, so talk to the production department. But it will prevent my application from breaking down. Logging, as I told, I had an application that run, I think 385 jobs in a single day, 24 hours. You can't, I mean, we can't go through all the log files to see whether things is going on. And so to actually have some kind of logging where we log into databases, it's a very powerful way of doing that. We can also use it for the log files, FME log files is great for debugging, but you can see whatever going on all the way down the pipeline, but and what's reading and writing and so on. But with 300 jobs a day, you can't do that. So, but we can also use it for documentation, for internally the department saying how much data is we actually sending out, and but also we can document in relation to customers saying, oh, we didn't get the data last month, so yeah, it was running and we sent the mail. I have 5 minutes. And it gives a great overview of the application state. So here's just example. So we have a master, and then I create some XML files, and so we have, for instance, log files here from the date and a batch file. It's a view of the actual log file. I'll dump out this. But we can also read how many features were in a given table, not only today, but also a whole week back or 11 days back. We can see changes in there. So it helps us give and we can see the timing as well. And it's all based on the same log table in Oracle. Yeah, pre-processing, we can do a lot of pre-processing with TCL and Python. We can delete old data sets, see we have a clear environment. We can do post-processing, zipping, emailing to customers or to ourselves in case there's an error. We can log, we can move results to FTP databases and so on. So, yeah, we use the FME Begin and TCL to do this. And the result, FME server has some post and pre-processing, but by moving it into the mapping file, it will run even on a desktop. So if I run my mapping file or my script on a desktop, I will also get the logging there. I will also get the error handling, so in case somebody else's organization is using and having errors, I will get notified that something went wrong. So in my summary, I've tried to talk a bit about the different things around mapping files or around our projects, more than things I also think should be on the agenda. A lot of the presentations is focused on very interesting but very concrete projects, and by having we also need to talk about that. So all the examples, all the things I've talked about is running at the National Survey. So it's not all about data, but also a lot about structure, architecture, design, logging, handling, and post-processing. So I think my time is up.
Thanks, Peter. Also, don't be afraid.